Welcome to another Project Blue at Summer live chat. This week, we're excited to have Dr. John Fram from Oregon State University join us. But before we get into that, we have an exciting week ahead. We just announced back-to-back webinars on July 16th and 17th, focusing in on the ocean economy's role in the post-pandemic economic recovery and mobilizing an ocean economy workforce in California. We have a star-studded list of panelists. We have Altasea's CEO, Tim McCosker, the CEO of the Los Angeles County Economic Development Corporation, Bill Allen. We have Holdfast Aquaculture co-founder Kelly Stromberg, Blue Robotics founder Rusty Jahangir, Milken Institute Director of Public Policy Matt Horton, Santa Monica College Dean of Workforce and Economic Development Dr. Tricia Ramos. These two webinars will be moderated by, one of them will be moderated by a multi-Emmy award-winning journalist, Val Zavala. And the second will be moderated by Planning Report and Verde Exchange, David Abel. This will take place on Thursday, July 16th at 10 a.m. and Friday, July 17th at 11 a.m. For more information on how to sign up on the series, please visit altasea's-project-blue.org/webinars. And also on July 17th at 1 p.m., which is a different time than usual, we'll be having a Project Blue at Summer live chat with Dr. Geraldine Natz, whose title is No Limits. She's a professor at USC. She's the vice chair of Altasea's Board of Trustees, and she'll be talking about her recent book, Port of Los Angeles: Conflict, Commerce, and the Fight for Control. To sign up for this, please visit altasea-project-blue/live-chats. I'll put both of those links in the chat for your ease of use. Now I want to introduce our special guest, Dr. John Fram. He is a coastal physical oceanographer, and his focus is on building an oceanographic research community that shares quality field data as soon as they are collected. If you have any questions for Dr. Fram during the chat, please send through the chat and we'll ask him during the Q&A session towards the end of the hour. Dr. Fram, thank you so much for joining us live from a boat, and I know you're going to take us on a tour of that. So with that, take it away.
Great. Well, thank you for the introduction, and thank you everybody for joining today. My name is John Fram, and I'm talking to you from the research vessel Thomas T. Thompson. It's a vessel operated by the University of Washington, and I'm from Oregon State University, but this ship is used by researchers all over the country or all over the world, and this is a ship that's capable of going to anywhere in any ocean in the world. So the work that I'm planning to talk to you about today, we were supposed to be at sea starting April 1st, but obviously everything changed in March, and the U.S. research fleet went back to its home ports and just restarted July 1st. So the cruise that I'm on is one of the first to U.S. research cruise of the summer, and I'm really excited to be able to go to sea again and do the work that I've been doing for many years. And I'm happy that to be able to tell you about what we're doing. So as always, when I go to sea, things don't go as planned. I will give you a tour of the ship, but they're currently, we're doing some work on the back deck. And so there's some places that I'm not going to be able to take you because we have work actively going. We're also really close to shore right now. We're about a mile from the coast near Newport, Oregon. And you might be able to see in the video some kelp flies, and I'm doing my best with them, but they're joining us today as well. So let me start my talk, and it's going to be about 20 minutes, and then I'll take you on a tour on part of the ship. So and so I think that the title that went around with kelp beds, coral reefs, and Arctic lakes. And that is work that I used to do, but I'm not currently doing right now. I'll talk about these things and how I transitioned from that work to what I'm doing right now. But what I do right now is I'm the manager of the endurance array portion of the Ocean Observatories Initiative, which is a large National Science Foundation project to enable scientists to observe the ocean. So the title I'm going with is Eyes on the Sea, How We Observe the Oceans Even in a Pandemic. And so that's what I'm going to talk about today. And if I could just show you a little video of what we're doing out here before I go do a tour. So what we were doing yesterday, this is a video taken not yesterday, but on a previous cruise that we were doing the same work that we were doing yesterday. This is on the research vessel Sequoia, which is operated by the University of Alaska. And in this, at the Oregon State University pier, in the background, you can see the NOAA pier that we were doing the same work on yesterday. And you can see that we're craning on these large buoys and then the rest of the moorings as well. And these we take to sea every 6 months, and then after 6 months, everything is kind of beaten up enough by the ocean that we got to go get it and put out a refurbished set. So we usually do that every fall and spring. This year we're doing that in the summer, and you can see the rain starting to happen there, which is a common occurrence in Oregon. This is the work that we're planning to do today, although we had a little, not a mishap, but things didn't go as planned this morning, so this is what we'll be doing tomorrow. And this is how we recover these large oceanographic moorings. They're about 2 stories tall, the buoys that you see right there, and it takes about 10 of us in our science party, and then the ship's crew is about 23 people, so it is on this ship right now, and so there are a lot of people that have to make this ocean observing happen. And so here you have the buoy, and you'll see the rest of the mooring coming on deck shortly. What they're bringing on board right now is a frame with scientific instruments that stays about 7 meters below the surface. And
Ready?
Hey, Dr. Fram, you're muted. Can you unmute your mic? Should be in the bottom left corner of your Zoom screen.
okay, can you hear me now?
Yep, perfect. Thank you.
Oh, great. So sorry about that. How much did you miss?
Probably 20 seconds, 20 to 30 seconds.
Oh, great. All right. So let's go back and move on to the rest of what I have for you today. So that's the work we're doing out here, and that's why we're doing it. Here we're clipping onto a buoy in rough seas. Right now, since we're doing the work in the summer instead of the spring and fall, it is super flat, calm, and everything's going really well in terms of the ocean cooperating with us. So what I wanted to start with was like, why why observe the ocean? So observe in the sense that why collect data for a long period of time at one point instead of just taking a point measurement. And that's because we need to put the data into context. And going to sea is, well, it's challenging and it's super expensive. And so we need ocean observatories. The data that I'm collecting is, you know, it's far more expensive than one research group can get funded for themselves. And so if you're going to bother collecting it, you might as well share it with everyone because it's, you know, it's such a challenge to get. Not only is it expensive, conditions can be really tough. So in the winter here, we get seas over 40 feet and winds, hurricane force winds. And it is difficult to make things survive here year round. So collecting data year round, year after year is super hard. And so, well, there are some scientists who are, you know, have their own interests and use our data. There are scientists like myself who focus on how to collect data in these rough conditions, you know, rough seas that we have up here in Oregon, to the deep depths that we go at, you know, dealing with high pressures, and the corrosive waters. So everything gets corroded that we put out there. There's also things like biofouling that you'll see that are a real challenge to deal with. And so there's science to that, in addition to the, you know, other work that a more typical scientist would do.
Hey, John. Oh. Stick with us, guys. His connection's a little bit bad. He's on C, so we'll get this back up and running in a second.
Okay, can you hear me again?
Yes, sir. We also cannot see your PowerPoint.
All right.
If you have your PowerPoint on, we can't see it right now. There we go.
Hey, how you doing now?
Perfect.
So this is kind of how it can be. You have plans, and then you just see, and they get changed. So I'd like to tell you about different ways that oceanographers observe the ocean, and then how specifically the observatory I work, the Ocean Observatory, observes the ocean. So this is an image from July 8th of all of the different Argo floats that are going in the ocean right now. And you can see there are almost 4,000 of them. And what this program does is it has thousands of floats that are all the same, that are almost all the same. And they profile once every 10 days in the, up to the surface, send their data home, and then drift off to wherever they go. And they take about 5 years before they stop working. And so this is a program that is one type of observatory where you have many of the same thing. The other three that I'm going to talk about are observatories where we collect many different types of data. And so this is the first type of observatory that I got involved with when I was doing the original title of the talk, Kelp forests and Arctic lakes and coral reefs. So my first job out of school was to work for scientists who had doing physical, looking at the physics of these three types of systems, and wanted me to analyze the mixing data that she had. And what we found is that in order to put our data into context, to kind of give a reason for why you would look at mixing in Arctic lakes or kelp forests or coral reefs, that we needed all of these other types of ecological. And so the National Science Foundation has set up a long-term ecological research network, and there are 28 sites around the world where you can go and study a certain setting. So there's one in Santa Barbara Channel that focuses on kelp forest ecology. There's one in the North Slope of Alaska that focuses on Arctic lakes. And so I I looked at data from those and worked with those communities of ecologists for a couple years, and then I moved on to another place where I was doing work with a different type of an observatory, the Integrated Ocean Observing System, which is funded by by NOAA, the National Oceanic and Atmospheric Administration. And instead of focusing on a setting like the LTR network, it's focused on region. So I'm in the Pacific Northwest region, and so the IU's program here has found all the different groups that are collecting oceanographic data. There are 17 federal agencies and many state and local groups as well, and made a website that makes all of those data either shows where those data are available. And this is really useful. And so I was a big user of data from the IU's programs that I work with, and think that these kinds of observing systems are of great use. And so when a job became available to work collecting data from those observatories, I applied for it, and that's what I'm doing right now. So I work for the Ocean Observatories Initiative, which is also a National Science Foundation project, and it's managed by the Woods Hole Oceanographic Institution in Massachusetts, and includes groups from University of Washington, Oregon State, where I work, and Rutgers University. And the Ocean Observatories Initiative, or OI, has arrays in 7 places around the ocean. The 2 ones in the Southern Ocean, I have a little cross because we have data for 2 years there, but the funding didn't work out. But the other parts of the observatories are still going strong. The part that I manage is on the screen shown by 2 yellow bars. That looks at the coast of Oregon and Washington, and it's called the Endurance Array, because we hope it endures for the full 25 years of the project. I really hope that happens. There are other parts of the observatory in the Gulf of Alaska and in the Erminger Sea. There's a part that's cabled on the seafloor here out to the plate boundaries. So we've folks from the University of Washington, part of the project has fully instrumented an undersea volcano that's further off the coast from where I am right now. But I'll talk about the parts where we're looking at the water column off the coast of Oregon and Washington. All right, so let's go to the next part here. So this is the Endurance Array, and let me go back one slide, sorry. And what we're trying to look at here is things along the coast of Oregon and Washington, so north and south of the Columbia River. And along the coast, we have moorings and profilers on the shelf, which you can see by the circles and triangles there on the map. And then to give the kind of broader context for the places that we're working, we have an array of gliders that are underwater robots that go along the paths that you see over there that help us put what we see on the shelf, measurements we see on the shelf in context. We have a total of 279 instruments that we're sending data to shore on, making measurements. All right, can you hear me again?
All good to go. Yep, hear you perfectly.
All right,
your
fantastic.
Slides need to be reshared though.
All right, I will do that. Yeah, apologize for the technical challenges. This is one of those days. So we tried something this morning, and I'll tell you about it when I take my good tour. Let me talk about the things that we're putting in the ocean. On the left side of this screen is a picture of the 4 gliders that we deployed a couple days ago. And you can see in the middle, one of them floating in the water. These are really amazing underwater robots. They can go, they're about 6 feet long, and they can go for 3 months at a time, and they go up the surface to the bottom of the water column continuously for those 3 months, which is just astonishing. And then sometimes a day they come up to the surface, they have a satellite phone and they send data back to shore, and we send put those data online immediately. As you can see, there's no propeller on these gliders. The way they move is they move like a nautilus, the animal shown in the top right of the screen. And so the way the chambered nautilus works is it moves fluid in its chambers to change its volume. And so when it compresses, all right, I will share one more time. Okay, can you hear and see me again?
I can hear you, and the screen sharing starting, so all good to go.
All right, fantastic. So these gliders work like a nautilus, and that's how they're able to be so efficient and to be out at a time. And that allows us to operate them efficiently, because again, it's super expensive to go to sea. But if we only have to go out every 3 months to pick these guys up, then we can do it. And they move slowly, about 1 foot a second. That's enough to get across the shelf in a week and up and down the observatory on the west side about once a month, which is about how fast things change. So let me move on to the next thing. Here's what we're doing on the shelf. So the main thing we're doing on the ship right now is deploying these large moorings, and adjacent to each of these moorings is a profile. The moorings measure stuff in a couple of places continuously, and the profilers go up and down a few times a day. Right. How about this? Why don't I switch gears and go to my phone and give you a tour and answer some questions? Because I think the presentations is getting a little challenging, starting it every few minutes. Does that work for you?
That works great. Yeah, we can do that.
Let me switch right now over to my phone. All right.
There we go.
So can you see me now?
Yep, we can see you and we can hear you.
All right. Great. So for me to be able to walk around on deck, I need to wear my safety hat. So I'm going to go off right now. Okay, so let me show you one of these moorings that I just spoke about. Here's one on deck, and the things we're doing here is we're measuring at the surface. We're measuring things like the meteorological measurements, so wind and temperature and pressure and rain and sunlight. And then also in the picture here, you can see the different ways that we send data to shore. So close to shore, it's by cell phone, and then further off, it's by satellite. And when we're close to the moorings, we can, they have Wi-Fi. So when we're really close to them, we can talk to them quickly over Wi-Fi. And then we have backups for everything. You can see that we use wind and solar on these moorings. And so that's kind of why they have to be so big. They're about 2 stories tall, because the instruments go kind of above the wind and solar. And in order to make the whole thing not tip over, we need this large buoy at the bottom that's about 3 meters or across. And the wind and solar give us about 200 watts, so a couple of the old style light bulbs of power, which is a lot for oceanography. And that enables us to do all the work that we do. So let me move down a little bit. And so here are the other things that we're doing. So we're measuring partial pressure of carbon dioxide in the air and seas. So we're able to look at issues like ocean acidification. We also measure pH and other important things for that issue as well. We measure dissolved oxygen, which I can show you the sensor right here. And then we use, and dissolved oxygen is a big issue in Oregon, because during the summer, when low oxygen water is upwelled onto the shelf, in the last 10 to 15 years, the oxygen level has gotten low enough that it is hypoxic, which is, it kills the sea life here. And historically that wasn't observed. So that's just been observed episodically starting about 15, 20 years ago. And then now it's really an every year event. And so we are collecting a long-term time series of oxygen and many other things as well. We like to say we measure everything from physics to fish, so physics, chemistry, and biology. And instead of going through each of the different sensors, if people have questions, I'm happy to talk about how we're doing any of those things. And what's happening right now is that folks are on deck, and we're trying to recover some gear that we tried to, it was on the seafloor, and we sent a signal to an acoustic release there for it to come to the surface, and it didn't. And so we've spent the last few hours trying to drag for it, and that's why we are where we are. So I do have a lot more to say and to show you, but I think, why don't we transition to questions, and I'm happy to answer questions as I show you the rest of the ship.
Awesome. Awesome. So we got a couple that came in. Let's see which one is first. First, we have one person, kind of a random question, but they want to know, what is your favorite ocean to research in, I guess?
Sure. So I've only worked in the Pacific Ocean, but before I worked here, I worked in Hawaii. And that was definitely my favorite, because when I worked in Hawaii, I could dive to my research equipment and do most of the work as a diver. The water was warm, I could see where things are. But here, when something goes wrong, like today, where we have to recover something on the seafloor, or the water here is turbid and rougher, and so we have to drag for things or use ROVs. And I really enjoyed when I was in Hawaii that I had more kind of physical contact with the work that I was doing.
Gotcha. Thank you for that question, Ryan. Nancy asks, since research cruises were canceled because of COVID and are just now ramping up, how is it decided what cruises happen when? Who gets priority?
Sure. So we all put in an application and explained why our work was the most important. There was different, so we had to show why we were both important and safe. Important in that what we do in our project is ocean observing. So our data are used by many scientists and not just one research group, and that we're collecting a long-term time series. So continuing that time series is very valuable. And so that was our main argument. And then in terms of safety, our group, we were ready to go when things got shut down in March. we were pretty much ready to go on our cruise at the beginning of April. So it was okay for us not to be in the office for a few months, which is pretty much what happened. So when things restarted, we were ready. Our group all lives in Corvallis or near Corvallis, so no one had to travel to get there. So that's why our research, and we also needed a small group of scientists to go to sea. So we only send 10, and this ship can hold, I don't know how many, but about 25 to 30 scientists. And so those are the reasons why our work was prioritized, which we're super thankful for. The challenges with the pandemic were, how do I put this? So I'm the project manager, so I was the one going to all the meetings every day about how to respond to this crisis, and how do we get our work done in our lab? How do we show that we're protecting our employees and particularly our students? And then all the different measures we worked with the ship operator. Actually, really, it's the ship operators that drove a lot of the safety conversation to figure out how we can get to sea safely. Because there's 33 of us on a ship, and so there's obvious concerns.
Awesome. So actually, what would a day in the life on this boat be for you? What's your typical regimen?
Sure. So a few of us will get up at 6 or 7 and set things up for the morning. Breakfast for everyone is 7:15 to 8, and then the whole group meets on deck at 8 o'clock to start work. Lunch on the ship is at a set time every day, and dinner as well. And so we try to do the large operations between 8 a.m. and 5 p.m. And then we have operations after dinner that hopefully require a fewer number of people, so that the ship's crew and the rest of the science party can be done at sunset, which right now is pretty late. And then I spend a couple hours after that writing down everything that happened today, and I send a report to Washington, D.C. about what we did. It's usually, I said, we go either in March or October on this cruise, and so we're in the summer, and so we have many more hours of daylight. So one of the challenges that I have is I'm used to just starting full speed at dawn and stopping at the end of the day at dusk, but now that's many hours longer. So trying to be careful and respectful of everyone's time and not working too many hours.
Awesome. All right, so we had one emailed in from Jeff, and it's a little more scientific of a question. So he asks, kelp losses and consequent nearshore ecosystem services have been dealt a severe blow with the proliferation of purple urchin barrens along California and Oregon coasts. The entire San Miguel Island, including the state marine reserves, are virtually devoid of kelp. In Monterey Bay, sea otters and predatory fish are not voraciously eating these urchins, as they are virtually devoid of gonad and thus have very little nutritive value. Do you have any suggestions or remedies to remove these urchins and restore these once persistent kelp forests?
So I do have some ideas, but since that isn't my area of expertise, I'm going to try to be a good scientist and not comment on it. So I don't have a remedy that I think I want to put my name to. So I don't have an answer for that. What I do here is I collect the long-term data that managers will use to answer questions like that, and certainly the Santa Barbara Channel long-term ecological research project that I used to be associated with collects those kelp population data that are used for those decisions.
Got it. That's okay. So we had another question about your area of expertise. Then we have Ruby is thinking about doing a degree in geography with oceanography. What did you study at university, and what made you choose to work in this field? And how did you end up in this field as well?
Sure. So I was I studied physics as an undergraduate. Um, where I went to school didn't have oceanography as a major or as even as a class, and still doesn't. Um, and so, you know, if I had known earlier that this is what I wanted to do, a place like Oregon State University that where one can major in oceanography or in climate science would be a place that I would want to go. The large state universities on the West Coast really give those options, and not just to take classes, but to do research. I had a great opportunity, I guess, in high school to do research, but not in oceanography, but in geoscience, and that experience definitely made me choose this career as a field scientist, but not as an oceanographer. So my sister is a geologist, and I worked as a field assistant for her, carrying rocks, and that's where I you know, got the motivation to do what I'm doing right now. Um, how I ended up in oceanography it took another 10 years.
Got it. Got it. So okay. So kind of going off of that, say we have some high school or some college aged people in here. What is your best advice to someone that's kind of interested in this sort of work? What is it to any nonprofits, any volunteer positions that you know of that you would recommend to them, any organizations, that kind of stuff?
So um, for me, there's kind of the inspiration part and then the being useful to a lab part. The inspiration part is, you know, for me, I had great field experience with my sister. And then at universities like OSU, like we hire, well, not during the pandemic, but normally we have half a dozen students working for us. And I think that's, um, I think that's really helpful for students so that they can figure out if this is the kind of work that they want to do. And it's super fun. I mean, I love going to sea, and it doesn't take long out here to get people interested in doing it again. And so we try to make those opportunities available as much as we can, and try to get people from other universities as well who don't have ships like OSU does. Um, uh, it's frustrating not to be able to do that so much this year, but you know, that's where we are. In terms of how to be useful to a lab, there are many different ways. So, I mean, for me, my background was in physics, and I'm good at crunching numbers, and so that's why people hired me initially to do research. But you know, the research group that I have has people whose background isn't that, and one of my best friends here is his background is as a motorcycle mechanic and a bike mechanic, and so he works in a lab making scientific equipment here. And so there's the neat thing about oceanography is that it is interdisciplinary. It requires chemistry, physics, biology, geology. There's this complicated field work, and so you don't necessarily need one skill set to be useful to a group, but you just have to be kind of willing to work in a variety of ways, and to be, you know, valuable in whatever your talents are.
Awesome. That's great advice. All right. So we have a couple very non-scientific questions here. So
Sure.
we know you're on sea. So Jeremy wants to know, what are your favorite things about being on the boat, and what's the least favorite parts about being on the boat?
I think my favorite thing about being on the boat is that I get to do this all day. So I get up at 6 and I'm doing this till midnight, and I get to be with the people that I work with all day. It's looks kind of weird right now because can't be as close together as we normally are. But the people that I work with, there's a camaraderie that you have when you're at sea with them that lasts, you know, the rest of the year. And I really like the people on the ship here. This is a ship that we hadn't been on in 3 or 4 years, and I really enjoy working with the people here on the Thompson. So I think that's my favorite part. the least favorite part is not seeing my kids. You know, I had to do a 2-week quarantine before we came to the ship. So for this, you know, 18 days of work on the ship, there's, you know, an extra 2 weeks of also being away from them as well, which is definitely the worst part of this.
Oh, so that kind of brings me to another question. Two-part question. Where do you see the research, where do you see your work going now with all these COVID restrictions, and what safety precautions are now involved besides just 2-week quarantine, which is a burden of its own? What are the things that are going to change about your field in the next couple of years because of this?
So one of the things that this observatory does is we don't just deploy the instruments that we you know, have as part of our project, but we have these outsized moorings and other platforms that can take instruments that other groups have. So we have on this cruise 3 different researchers who sent in the mail their instruments to us, and we attach them to our moorings and are deploying them. So, you know, with fewer people able to go to sea, we need to work together. And so projects like this one, where we can deploy things for other people, are going to be more important. The particular complications of getting on a big research ship are, you know, we reduce our staff, we get COVID tested before quarantine, and at the end of it, we socially distance on the ship, which is complicated because, you know, there are other safety issues. I mean, the reason why I have a hard hat is because, you know, we're moving around 9,000-pound buoys on normally a moving ship. During the summer, not so much, but we need to be able to work shoulder to shoulder and to talk with each other. And so there are limitations to what we can do. I think they can be worked out on a big ship because it's, you know, it's expensive. And so the extra expense of going through whatever mitigations you need to go through, you know, you can kind of do it within the budget. On small ships, it's really hard because if you just want to take a day trip, you don't want to do a 2-week quarantine before a day trip. And so we're also working through the challenges of doing small boat work. You know, there are different things we do to make that experience safe for people. I think in my own group, the small boat work we need to do for, you know, recovering and deploying these gliders, for example, we could just do that with our own staff because we have enough people with that skill set. But other researchers usually rent or charter one of these vessels, and it's going to be more difficult for them to do it. Maybe they'll have us do that work for them.
Awesome. So Eli, about the gliders, he asks, do you take physical samples or exclusively use field instruments to collect data? And he also wants to know, are the gliders the only instruments you use to collect data at depth?
No, our moorings and profilers go to the bottom of the seafloor as well, and we telemeter that data to the surface in near real time. In terms of physical samples, let's see, right behind me, you can see this rosette here. So each of those bottles we can fire remotely. And so whenever we deploy or recover something, we put the CTD rosette in the water, and I'll explain what the acronym means in a minute. And then at each different depths, we collect the water sample, and then we process it in the lab in the back here for oxygen and nitrate and other chlorophyll, other things as well. And then on the bottom of this rosette is something that measures conductivity and temperature and depth and fluorescence and oxygen, in this, using the same types of instruments that we have on our moorings and gliders. So we can compare the bottle samples and then the samples from the profiling instrument on the rosette against our data. And that's important for validating it. Also, the ship collects data. So there's a flow-through system on the ship. And so we get continuous surface data. And so our instruments on the surface, since we're, at each site, the ship sits there for a day or two while we do our work. We can compare those against the ship's data as well.
Awesome. Awesome. So Darlene asked, actually, she asked a good question. What are the flies we see attracted to, and are they on the ship all the time? And
They're
also,
attracted to me.
from a question from me is, do you get used to that? Because I see a mosquito, I'm swatting it away. Is that when you're on the ship? That's just life, huh?
No, it's not just life. It's just where we are right now. So where we are right now is about a mile from shore in Newport, and there are kelp beds all up and down the coast here, and there are flies that are attracted to the kelp, particularly the rotting kelp on the beach. And we're close enough to shore that they made it out here, and they weren't here immediately, but we've been here a few more hours than we'd planned, and so they're definitely around me, and I'm not used to them and don't care for them, but we'll be done with them shortly.
That's awesome. Well, I think that's it for questions. I don't think I missed any. Do you have anything else you want to talk about?
Well, let's see. I can take you into the lab and show you what the lab looks like here on the ship. So let me turn the camera around, and you can see that. So here's how close we are to shore. There's the lighthouse in Newport, and so I'll walk right now into the lab.
Awesome.
So the Thompson is a ship that's about 30 years old, but a few years ago it went in for a midlife refit. So while some of the things still do look 30 years old, everything kind of behind the scenes has been repaired and replaced, and so it's in great working order. So this is the main lab, and then in the back here is all those screens. I won't show you in detail, but they are the scientific instruments that are the ship measures, and they show us as we're collecting our data what the ship is measuring. So for example, right now what we're doing is we're trying to drag on the seafloor to look for this troublesome instrument that didn't come up, and we can see it on the sonar, and that's helping us maneuver the ship to where we need to be to drag for this device.
Awesome. Well, we know you have to get going, so thank you so much for your time.
Okay.
Thanks for working through all the technical difficulties with us. I know being out at sea is not conducive to great internet connection. So again, thank you so much for joining us, and be sure to check out our website at altasea-project-blue.org to sign up for our webinars, our live chats, and more. And Dr. Fram, thank you so much. This was awesome.
All right, thank you. You have a good day.
You too.